Hi, good afternoon, good morning, good evening, and welcome to another real-time data webinar. I'm your host, Matt Eddy, and thanks very much for dialing in. Hopefully everyone can see the screen. We've got a packed agenda, so I'm not going to spend too much time talking through all of the different things that we've got going on, but I will step through to the agenda. So, by way of introduction, I'm also going to talk a little bit about the logistics that we've got. Might be a slightly different webinar platform for a few people that have joined these before. There's a lot going on. We've got Q&A sections, we've got media, we've got the different links to look at, and then hopefully you'll also see the video camera of the presenter, and then also the PowerPoint that we'll be walking through. There's widgets that you can adjust. You can change the size and the scale of the different windows so you can see what's going on. That's going to be important later on because we're going to be doing a live demo later on. So you might want to kind of expand that out to get the full screen. So we'll probably be running that on like font 6 size text. So you're going to want to get that as much as possible onto the screen. But we'll start off with a brief introduction. I've got a couple of slides I just want to run through before we get into the meat of the topics. We're going to go through some roadmaps. We're going to also talk about what was the ADS POP, which is now the real-time connector. We'll have a fine jar in for the team if anyone gets any of those wrong. So please do flag that. We'll penalize them later. So Brian and Mahesh are going to walk through the reference architecture for what we do in the cloud and hopefully give you an idea about how that's going to help you. We're also going to have some live Q&A with Jeff and Ted talking about some of the common asked questions and some of the themes around DACS that people are asking us. And then we'll bring it all together into possibly an over-optimistic demo. We've got a lot to pack in a short period of time to do it. So there's a lot to go on there. And then we'll wrap that up with kind of going through our development leads and asking them what are they working on over the next quarter, what can you expect to see out of the product, but then also in terms of documentation, developments, and what are we working on for the longer term as well. So then we'll wrap up with a close and just sort of next steps. We're going to be doing some poll questions as we go along. So we'll give you a chance to answer some of those just to make sure you're still paying attention. So click on those as we pull them up, and I'll give you a chance to do those as we go through. Okay. So if I step down through to the next slide, just briefly going through the presenters we've got, obviously myself there, and Jeff from the product team. And then beyond that, we have Brian, who leads the development team for real-time, and his team there as well. We're also missing one name off there, Xiaoming, who's going to be doing the real-time and the GCP demo later on. So apologies, his name's not there, but we'll try and get his email address into you at a later date as well. Okay, so before we dive in, there was a couple of things just to update you on. So I think the last time we did a customer advisory forum and the webinars, we were a Refinitiv company. Now we're an LSEG company. London Stock Exchange acquisition closed beginning of February, and we are now part of the LSEG business. So what you're seeing on the screen at the moment is kind of the customer-facing mission statement and the purpose of the company. But I just wanted to call your attention to the text I've highlighted in blue. The openness, the partnership, the delivery of excellence. Hopefully after 90 minutes of listening to the team here, you'll agree that that's what we're doing here. So that's our aim, and that's what we'll be working through. So see whether that is the case. In terms of what LSEG spans across the globe, 70 countries, really diversely split across the globe. As you'd imagine, a heavy presence in UK and US, but a large presence in terms of people in Asia as well. So it's a really great time. There's a lot going on in terms of the commingling of the heritage companies, bringing them together, identifying opportunities, and learning about how we can just make the business even better. The other point that I wanted to bring to attention was the last forum that we ran in November was probably the first hour we spent talking about rebranding. Again, moving away from Thomson Reuters and into Refinitiv, there was a heavy bias on what the implications are around continued support from our products. So We aren't going to be rebranding again. We are going to be Refinitiv, so don't worry about that before anyone posts that question. But we did want to highlight again, post the end of July, the only versions of software we'll be bringing out will be Refinitiv branded. So if you're working on an older Thomson Reuters version and you have issues with that, we can only give you bug fixes for those for the Refinitiv branded and newer versions. So that's a really good reason to get on. The other even more compelling reason, though, is because all of the stuff we're talking about today, all of the stuff we're showing you is only available in these newer versions that are post-rebranding. The rebrand was 3.5. We'll be talking about 3.5.1 and DAX 7.7 and onwards. So all of the newer versions and all of the new capabilities. So it's really important that you get up to speed for those versions. Stuff isn't going to stop working, but we want you to have the best experience possible. If you missed that webinar, then the link at the bottom of the page, you can see the presentation, that has a link to the registration page. You can watch a recording of that and get much more details around all of the different software products we offer and about what you might want to do with them. Okay? So with that out of the way and only taking up 6 minutes, I think we're doing good on time so far. I'm going to hand across to Jeff, who's going to run you through the RTDS, which was TREP. Remember, that is the old acronym. RTDS, Real-Time Distribution System, is the new acronym, and DAX. And so, Jeff, I'll move on to the next slide and hand over to you, please.
Yep, thanks, Matt. And good day, everyone. Thank you for joining us for another presentation and a roadmap review. The Real-Time Distribution System roadmap includes a list of our large enhancements that we are either working on or we've already delivered. And in addition to the large enhancements, there's always a number of small enhancements and bug and fixes that we include with each release. So I don't mean to be repetitive, but if there's some new people on, what you should know is that a large enhancement can take 6 to 12 person months of effort. A small enhancement can take up to 6 person months of effort. So that's the distinguishing feature there. And so the roadmap, again, focuses on these large enhancements, but the what's new doc that we release that's included with every quarterly release also includes the full list of small enhancements and the bug fixes. And the what's new is always available to download on My Refinitiv. So we just delivered a number of new features at the end of March, Q1, which includes level 2 delayed data. So now, in addition to level 1 delayed data, which is market price or domain 6, we also offer delayed capabilities for level 2 data, which now includes market by order and market by price, which are domains 7 and 8. And the reason why I'm mentioning the domains is that this enhancement also covers customer-defined domains. So that'll be useful if you, let's say, integrated any exchange data into some derived calculations that you then provide to consumers. So the benefit here of having this delayed level 2 data available is where, for instance, conflation allows you to manage traffic rates, right? Delayed data allows you to manage your market data costs by reducing exchange fees for those consumers that don't need real-time data, all right? We also delivered cache resilience and persistence for level 2 data at the end of March. And cache resilience and persistence keeps data caches synchronized across primary and backup servers. This feature's been available for level 1 data, and we were asked to extend the capability for level 2 data. And this also includes customer-defined domains as well. So the benefit here provides for higher level of integrity or data integrity across multiple servers and faster recovery times in event of a restart or a failover. Right? Many of you know that have been on the other presentations or in active discussions with us about the cloud know that we've been running ADS POP at Amazon or AWS since fourth quarter of 2018. That's the source of real-time optimized. And our goal is to become cloud agnostic. Or maybe I should say your goal for us is to become cloud agnostic. So that's where we're heading with this. And as of the end of March, we also extended category A support for the ADS POP and real-time connector running at Google or GCP. So now that's a bit ahead of our original Q3 timeframe, But over the last couple of months, I should say last few months, several months, we've seen that a number of our customers are moving to the cloud at a much faster pace than they were initially expecting to themselves even a year ago. And so we've made a push to provide basically more options for you sooner. So that one we moved up. GCP is now available, as well as AWS with ADS POP and real-time connector. All right. A big deliverable we have for Q2, which is on the fourth line here, is the real-time distribution system cloud certification at AWS. Now, this goes beyond just providing category A support for the ADS POP and real-time connector. You'll see the description is to create this predefined off-the-shelf RTDS deployment at Amazon. That's scheduled for this quarter, Q2. And then we'll repeat that at Google, and we'll repeat that at Microsoft, which means we'll be able to offer a full off-the-shelf deployment at the 3 largest cloud service providers by the end of this year, right? So the off-the-shelf deployment will address 5 criteria. It'll address architecture, licensing, machine images, both container and non-container deployments, and of course, support. And the reason for this is we learned last year that everybody has their own ideas of what a cloud deployment should be. And as a result, our professional services team that have been working with some customers ended up building a few of these bespoke solutions for customers because no one set of requirements were the same. Now, bespoke solutions may be appropriate and required for some use cases, but let's face it, they're generally expensive, they're not scalable, and they're not sustainable from a support model, right? So we expect to come up with this off-the-shelf deployment that will address the majority of our customer requirements for a solution that you can go manage yourself and that will be able to support if you call us in with a trouble issue, right? So if the public cloud does not have quite everything you want, there's also hybrid options that leverage some of our managed service capabilities. But again, I want to emphasize that this is an important deliverable that is intended to address many customer use cases. It's not meant to be for a bespoke solution, but a one-to-many solution, all right? Also in Q2, we'll offer warm standby and preferred route recovery. This enhancement was requested after we came out with asymmetrical load balancing last year. In the ADS POP or the RTC, we'll be able to automatically reconnect back to the initial or the preferred location before the failover had occurred. So the benefit here is you'll be reconnected automatically to your preferred location, which is likely to be your lowest cost route or the route with the lowest latency. And the reconnect will occur based on some predefined interval that you can set up, right? For example, you might want the reconnect to occur over a weekend. That probably makes the most sense, right? The point is someone will not need to manually make the flip to move you back to the preferred location. That's the point of that new capability, all right? Websockets Encryption is another multi-customer request that's scheduled for the end of June. This feature will embed encryption capabilities on the ADS POP, the ADS and real-time connector for WebSocket connections. And the benefit there is it provides a layer of security between the server and the consumer connections, right? By the end of Q2, last item on this page, we'll extend category A support for the ADS POP running at Azure, and that will extend our commitment to offer you cloud agnostic solutions at all 3 major CSPs by the end of June. So again, this is just ADS POP up and running at Azure. So again, we have it today at AWS. We've had it available since 2018. We've made it available at GCP at the end of Q1, and now it will be available at Azure at the end of Q3. So we're making good on our deliveries. It gives our customers more options if they're ready to move to the cloud and they have a preference, all right? Let's move on to the next one, please. Okay, moving on to Q3. Thanks, Matt. You'll see predefined off-the-shelf RTDS solution for Azure. We just covered it. It's the same that we're going to be doing for AWS. It's going to be the same that we're doing for GCP. But I just want to emphasize again, the 5 criteria we're going to address here is architecture, licensing, machine images, container, non-container deployments, and of course, support. Also for Q3, we'll release persistent mounts as a new resiliency feature. This means that the downstream server will be directed to reconnect back to the upstream server automatically so it can have access to the same watch list. And this is reconnecting to an actual server rather than just the location itself. And the benefit here, again, is to provide higher level of data integrity across multiple servers and faster recovery times at event of a restart or a failover. And this is a couple more examples, which appears to be this recurring theme with a number of our enhancements around resiliency. And the reason, so you understand, is without multicast in the cloud, right, we cannot provide source mirroring or hot standby, as many refer to this feature, right? So we're developing other options to give you higher resiliency and options for recovery in event of a failover, right? And if something develops later down the road that there is multicast capability, obviously we'll have that feature too, but we're working around the options that are available to us today and providing you with better solutions, again, for resiliency and failover, right? Now looking ahead to Q4 on line 3 here, we'll be wrapping up the year with Red Hat 8 support and native binaries for ADH, ADS, ADS POP, and RTC. And as the Red Hat site states, this will offer better manageability, improved performance, and improved security features. All right. But once again, I just said this before, but you also see the predefined off-the-shelf RTDS solution at GCP. That's currently scheduled for Q4. We've already discussed this. And the reason why I want to bring this up as I keep driving home the 5 criteria that we're including in this predefined off-the-shelf solution is we're already well engaged with GCP, as you'll see later on, and we're also looking to extend the list to include orchestration or automation, and also enhanced monitoring that will leverage our REST interface. So the 5 criteria is kind of like a phase 1, and we are looking to extend that to offer you more capabilities. And we may actually flip this Q4 deliverable at GCP with our Q3 deliverable at Azure. It really depends on customer demand for which one takes precedence. And we're interested in your feedback, and we're going to provide you with a survey question today. So please be looking for that, and then let us know the direction you're going in, because it helps us drive direction of where we're going. All right. Now, I'm conscious of time here. So let me move quickly. I'm gonna skip a couple of the other fourth quarter deliverables that we can come back to at our next presentation. The last item on this roadmap is small enhancements. And we normally don't spend much time talking about small enhancements, but there's 3 with the latest release here at the end of March that I just want to quickly bring to your attention. We already support running RTDS components in Docker containers, and we had a request to support Docker Compose. Now, Docker Compose is a tool that's used for defining and running multiple containers that allows you to create and start all services from your configuration with a single command. So as of the end of March, we have qualified Docker Compose, and we've added this documentation to the Docker manual. So that's a new feature that's worthy that customers have had asked for. And again, we're open to enhancement requests. So if you have ideas that you're experiencing, then especially moving to the cloud, then please let us know. And then the details for running the ADS POP at AWS were previously included in the Docker manual, but now there's a new document called Real-Time Connector Manual. And this manual provides details for creating an instance, launching and running the real-time connector in ADS POP at Amazon and Google currently, and we'll be adding the details for deploying the ADS POP and real-time connector at Azure at the end of June. So that'll be the new go-to manual for people that are looking to connect in the cloud. And then the last enhancement that I'll mention is something that a couple of our top customers asked for, And this is a case where a picture is really worth 1,000 words. Joe's delivered a significant performance improvement for the throughput of conflation updates, and Mahesh has prepared some test results that we're going to share with you. So Matt, if you can please flip to the next slide, and I'll let Mahesh take it away.
Thank you, Jeff. Hi, everyone. So yeah, like Jeff mentioned, we had a request from a couple of customers to run conflation at our minimum supported interval of 100 milliseconds. Historically, the requests have been to run at 330 milliseconds and above. But as we looked at the 100 millisecond, the performance was not that good. And so Joe made substantial changes in 351 to improve the performance of conflation. So you can see that it has helped across the board, 10% at like 1 second, but significantly at the 100 millisecond, we see a 5-fold increase. So these numbers are more in line with what we expect across the board as the cost of conflation. So this is great news for those customers who want to deploy it. So this certainly helps with the reduction of the server footprint when you use this capability. Next slide, please. At the beginning of last month, we released a performance results document for RTC. This is based on the version 3.4.2, which includes the item and the writer thread capabilities and the extension of performance you gain by enabling such threads on the Gen 10 DL380. We had a results document last year in August that we released that was using only the main thread, but this document is with the item and the writer threads. So if you take a few examples here, you will see that the full fan-out capability scales well, and we can really use up all the bandwidth. We see the numbers from 10 Gbps to 30 Gbps. This is all on the 2x8 machine. And we introduced the encryption of the RSSL data flow beginning with 3.4. So when we fully encrypt the message flow to 100 connections, we are seeing that there is a 20% cost of doing the encryption. All the configurations, how we do the thread binding, and all the CPU utilization reports are all in the results document. I'm just picking up a few to showcase here. And the next one in the middle, that shows the cost of conflation. So this was pre-351, so you only see from 200 milliseconds to 1 second, and you see the cost anywhere from 10% to 40% as you go to 1 second or 200 millisecond conflation. And the last one on the right-hand side, so this is the one that we have started to work. And what we are seeing is, and the cloud instances, so you see like, 2-core or, 8 or 16, 32, depending on the instance size you choose. So this one comes closest to the C5 9X large in AWS. So we have a 2x16, so that gives us the 32 vCPU, and we see like a 6 million updates per second with the item and the writer threads all on the same NUMA node. And if you span the NUMA nodes, then we are utilizing 15 item threads, 7 writer threads. And if you account for the interrupt handling, we are using up about 24 vCPUs out of the 32. We are getting 8.1 million updates per second there. And if we do the 100 millisecond conflation, there is a 15% cost. So it's still a very respectable 6.9 million updates per second. And as we go into the RTC architecture, you will see why these numbers are important. So I will, touch upon that a little later. So back to you, Jeff.
Okay. Thank you, Mahesh. All right, so now I'll run through the Dax Road Map. All right. The first line item here, we offered actually category A support for Red Hat 8 for the Dax server, the Dax sync daemon, the WANR, and the Dax libraries last summer with the 7.6 release. And the Dax station now supports Red Hat 8 as of the end of March. A little more testing going on with the Dax station, which is why that was delayed a bit. But so we're there. And then this is actually not a full new software release, but there's a technical bulletin available to download from my Refinitiv with the details for the configuration changes. And that'll be part of the link to the documents here for both the RTDS and Dax will be included with the with the follow-up that we send out. Okay. Now, the next 3 line items are, again, big deliverables for Dax Cloud certification. And just as with RTDS, it goes beyond just providing Category A support for running Dax in the cloud. It's basically the same deliverable and the same 5 criteria for Dax that we already discussed for RTDS. So I'm not going to spend a lot of time on this because we have a lot of other exciting topics here to cover today. But the point is that if you're consuming data in the cloud, you need a way to permission and report those consumers, right? There's a dependency for Dax, and it has to be part of our predefined off-the-shelf offering. So that's what we're working on, and we'll provide a cost-effective solution where you can manage your own infrastructure in the cloud, and then we can provide the support. All right, so stick around here because there's a demo later, as Matt mentioned, in the presentation that will feature both the real-time connector and Dax running at GCP, connecting to real-time optimized to AWS, and will illustrate, again, exactly what we're expecting to deliver with these predefined packages. So sort of a sneak preview of what's to come later in the year, right? The last item here on the roadmap for Q4 is an alternative to use an internet connection in place of a delivery direct connection for Dax to be able to connect back to the platform, to be able to synchronize permissions for Icon and workspace users. This is necessary because delivery direct is not available in the cloud, and it's also a cost-effective alternative for basically any location where delivery direct does not exist or is not available. So this is not just a cloud initiative. This can be used on-prem, private cloud, as well as public cloud. All right. So that wraps up my presentation. I believe Matt might have a survey question for you by now. Thank you, everyone.
Thanks, Jeff. A little bit early on the survey question that'll pop up in a little while. What we are going to be doing, though, is diving straight into the real-time connector reference architecture. So as we talked about, this is what we're already deployed in AWS ourselves. Mahesh is going to run you through a few sort of real-world scenarios and some considerations, and then he's going to hand over to Brian, who's going to go into much more of the kind of the day-to-day operations and how you might take advantage of some of the lessons we've learned, and also use that as a reference for yourself to move forward in terms of a topology you might want. So, Mahesh, I will pass over to you, and away you go, please.
Thank you, Matt. So, yeah, so in certain environments, such as the cloud, where there is no native multicast support at scale, we need a different architecture than what we are accustomed to. So a typical deployment, so we bring in data from multiple vendors, internal sources. The ADHS publishes the data onto a multicast backbone, and the ADSS, by interest, subscribes to different multicast channels and then provides the data to all the applications, WebSockets, the strategic RTSDK, legacy RFA, SSL. So that is the one that is typically in place. And now, with the lack of multicast support, we need to use a new architecture. And how we do that is by leveraging the capabilities of the RTC. So the RTC is in a nutshell, that's what it is. That is a software RTC. So it has all the capabilities of the RTDS except for the source mirroring. So we can stack up the RTCs and then
Mahesh, I think we're losing you as you're running through these slides. So
yeah, why don't I just take over for Mahesh, maybe?
Yeah, that'd be great, Brian. Please do. Thank you.
Okay, sorry, Mahesh. I know you prepared a lot of detail here, but and I'm probably not going to do as effective of a job, but I'll do my best. So what Mahesh had on the slide here, he was talking about the RTC, the connector. Essentially, some of you may know it as the ADS POP. The connector's rebranded. It has the key functionality of the ADS and the ADH, as Mahesh was saying before the communications issues. And it really helps us connect in environments that don't have support for functionality like multicast. In the image that's currently on the screen, it shows mesh connectivity with TCP. And we keep flip-flopping on the slides.
Sorry, Brian.
No, it's okay. Yeah, sorry. I'll since I have the next batch, I'll take control here. So in architectures where we don't have UDP, we move to leverage the TCP connectivity, and in some cases we have to use a mesh connection to scale, where with UDP you wouldn't have had to, because you have the benefit of multicast and the fairness that that provides. Inside of connector and for all of our TCP connections, we do process the data when we're sending it out to try to help still ensure fairness, even though it's sending to each connection physically. So there's still a degree of fairness, but it's not quite the same as with UDP. There are a lot of other things to take into account when you're scaling in these environments, how to employ conversion in the right ways, how to tune based on the hardware you're running on. The tuning with TCP and multicast are invariably different. So we have some links to different tuning docs for writer threads, item threads. UDP details are already there. There are a lot more information provided in the more recent documents. The most current is from March of this year. And these start to focus more on the connector. And as you start to look at that, you'll find more in-depth configurations that give you concrete details about how we've tuned it on G10s and in the environments that we've run in to achieve the performance that we're seeing in our labs and in the environments that we're running. So now moving into an example of a concrete deployment to give you guys some context into a scenario where we're running connectors ourselves in a TCP mesh like we just described. For real-time optimized, our service we provide in the cloud, we're doing exactly this. So what I'm going to do now is walk you through the ways we're running that service and the technologies that we're using, both from AWS, from Amazon, and the functionality of the connector or the ADS POP that we're using to achieve scale, cost effectiveness, and the resiliency that we need across regions and to allow customers to connect in with different protocol types and security. So on this slide, you'll see the image on the right. This is a zoomed in view of a single region in Amazon. Inside of each region, we have 2 availability zones so that we have in-region resiliency. And what we're doing is running load balancers, elastic load balancers from Amazon, and we have them set up in a specific way where we have 2 types of resiliency we offer to customers for connecting. One we are calling customer managed resiliency, where the customer can choose a load balancer that will route them directly to a specific availability zone, and it will always route them to that availability zone, no matter how many times they reconnect. And the other option is Refinitiv managed resiliency, where that load balancer will route them to any of the availability zones that we have. So that way you'll get a connection. You may not know which availability zone you're going to, but you'll go to whichever availability zone is least loaded, has available connectors. So in that scenario, if you want to ensure that that your component is connecting to a specific AZ, or you want to control the resiliency through a functionality like warm standby, client-side warm standby, you could control it and use customer managed resiliency and go to the load balancers that route you to specific availability zones and have deterministic, predictable behaviors where you'll connect into that AZ every single time. Once you're in that region and availability zone, we have essentially 2 tiers of components. And I'll zoom in on the next slide when I move to it to show you more details about how we're deploying the connectors in those tiers. But before I move on, I want to talk about some of the other surrounding components of this and what we're doing around that to both bring data in and push data out. So if you notice up at the top of that picture, in each availability zone, you'll see the arrows kind of going in and out. And we have connectivity to a couple different data centers that Refinitiv offers. And we're using asymmetric load balancing in the connectors to route content requests to those data centers based on the data being requested and where it's most likely to be able to be serviced from, and to provide an additional degree of resiliency. We have Chicago, and if you're in this example I'm providing, this is US East 1, so Virginia. And in one of the availability zones, we're going to Chicago, and the other we're going to New Jersey. But they're also still going to a different data center where we have legacy level 2 data synthesis and some other analytic data that we'll be bringing into the system. So certain requests will route that direction instead. And then if certain data requests aren't capable of being handled by New Jersey, for example, then it will route to our other data centers. And this helps us as we're migrating services from physical data centers over to new services and more effective connections, or into cloud and other places as well, because we can move things in the back end. Cloud is able to get it, whether it's coming from New Jersey or Chicago or our other legacy data centers that we may be rationalizing in the back end. And customers connecting down at the bottom through these load balancers won't notice the difference because we're using ALB above, and the connector handles it for us. We're using functionality, we're using the standard OAuth models in the connectors. So customers will request a token and they'll log in with that token. And it's using the same functionality we expose today through DACS in the connector that any customers can use. We just have a concrete implementation that we're using that ties into our RDP platform for customers to acquire tokens. And then we tie back into that system to authenticate and validate those tokens. When we're deploying in these environments, we're using CloudFormation today, which is an Amazon technology, and we're migrating our solution to use Terraform because, as Jeff mentioned, we're working to become sort of more cloud agnostic. And we want to set ourselves up so that we can be running in any cloud provider. As he mentioned, we support GCP today as well. Although this service is only provided in AWS, we want to make sure we have experience using other cloud technologies so that we can move services if needed, but also help with questions or customer issues that may come up with some of these other technologies that you may be using. So if I move ahead, now I'm zooming in to one of those specific availability zones with this slide. So still the same cloud, it could still be the same region, but instead of the regional view where you see 2 AZs and the load balancers and everything else like that, this is what's happening inside of a specific availability zone. So I mentioned that we have 2 different tiers of connectors. Essentially, the tier that the load balancers interact with, we call the fan-out layer. And that layer is set up for auto-scaling, and it's basically built to handle customer connections and content conversion. So in the slide that Mahesh was presenting, he was showing a cascaded connector that was handling SSL conversion to market feed, another one that was handling JSON conversion. We're not doing that in what we run in real-time optimized, although we could do that. But the reason we don't do that is because we want to make sure that the devices we're running are as utilized as they possibly can be for cost controls. So we're having these handle both JSON and RWF simultaneously. That way, as users come into the environment, regardless of the protocol they use, they're going to connect to a connector that's there. And as those connectors start to fill up, then we'll scale up a new one and grow our footprint. Whereas if we had JSON connectors running and nobody was using JSON, we're still paying for them. And it's just kind of a ticking cab fare that we don't want to have to do. If you look over to the bottom right, you'll see that there's different tiers that I've captured in a chart here. This is how we control the load on any of those connectors at that fan-out layer. So based on our knowledge of those protocols and the capacity that we can handle in the connectors on the instances that we're using in AWS for our service, we've determined the maximum watchlist sizes that can be supported on any of those fan-outs for those protocols. So we have those set up so users that have purchased a 15,000 item watchlist for us that are using RWF to connect will be routed to a small tier fan-out layer. They're all of our fan-out layer, they're all using the same instance size, C5 9 extra larges. I think I've got it on the next slide, I think. But the number of connections we handle on the small tier is greater than the number of connections we'll allow on the medium tier, which is greater than the number of connections we allow on the large tier. So that's how we mitigate the difference. And we've chosen the instance we use based on the network bandwidth and the capacity that they can handle. So we chose the size that gives us a 10 gigabit network, 10 gigabit guaranteed network bandwidth, because we need to ensure that we have that capacity across the board for any kind of customer engagement for this layer. So moving up from that layer, you'll see that TCP mesh, and I've coded it in blues and purples to show the connections to the caching layer. At that caching layer, we're running each we're running it as pairs of caches for resiliency. So there's an A side and a B side for every cache pair. And then we determine the number of cache pairs based on the universe of items we expect to support. And then between the fan-out layer and the cache layers, we're using the hashing that you can leverage in Trup today, and that we're starting to expose through the real-time APIs as well, because we're going to be pushing out functionality that's allowing customers to take more advantage of that functionality to support their use of TCP and environments like this. To help with rollouts, which I'll start going into on a couple of the subsequent slides, we're using a couple of more dynamic technologies to support our environment in AWS. So we're using Route 53 for DNS addressing and naming of our components, and we're using elastic IPs. So we have a range of elastic IPs we've set for all the different servers and connectors that will run across our environments, so that as we bring up and down environments, we have names and IPs that we can constantly be using in our config files. So as we start up new instances, or as instances scale and auto scales up, we don't have to know new IP addresses and dynamically figure out what a auto-scaled connector's address is on the fly. We know when it auto-scales up, we can have it take the next elastic IP, and we know the range of IPs, or we know DNS names that we've assigned for every cache that we've deployed. So the configs that those connectors are using will always go to a name that can be resolved that corresponds to an IP address that we know that can be controlled. And that lets us have some security in the environments, but also predictability, and have tighter control of our configs using some of these technologies in Amazon, but still have the dynamic abilities that we'd want to allow for functionality like autoscale. Yeah, I have it right here. We're using C5 9 extra large instance sizes. And like I mentioned, we chose that specifically because of the 10 gigabit network support that those offer. So I mentioned how we're using certain technologies to allow for us to do rollouts and sort of shut down components and bring up components. Before I start going through these slides, I just wanted to talk about a couple of concepts. There's an idea called continuous integration, and the idea is that software developers write code and they merge it into a branch that's ready to get tested, and then when it's tested and it passes the tests, then it can get built and rolled out and deployed. And there's then two additional concepts. There's one called continuous delivery, and that's where after that build occurs and the tests have all passed, the team or the ops team or the DevOps team make a conscious choice to roll it out into an environment, into a production environment, and now customers can engage with that version of the software that has those changes from that continuous integration build and that rollout. And then there's a third concept called continuous deployment. In that world, that takes it to the next level. And instead of having human interaction and teams sort of choosing consciously when to roll out that tested version of software, it's making that choice automatically based on tests, that automated test passing, and it's rolling out essentially every change as it's completed and automation passes. So you'll see very aggressive rollouts of those changes. What we're doing is we're not doing that. We're doing continuous delivery, where the team is engaged and working with ops to choose when we roll out. We're rolling out between every 30 and 60 days, though, because we want to roll out small incremental changes to our environment to control security. We're pushing out new images that have the latest security patches. We're pushing out new versions of our RTDS that have the latest software bug fixes, the latest features when we have it rolled out to customers. So typically we'll pick up those versions a couple of months after it's been put on my Refinitiv for customers to use, just because we're usually rolling out into the cloud a little bit behind the typical deployments of Trup, and we want it to be a tested release that's fully supported already before we roll it out here. So we've chosen to use a mechanism for deployment called blue-green deployments. So I've got a scenario, a couple of slides that I'm just going to go through and talk you through how we're managing that in our environment. The elastic IPs, the dynamic names that we use through Route 53 help us manage this as well. In this deployment, and this is what we do in any region, in any availability zone, it's consistent. And the CloudFormation and Terraform that we have, the infrastructure as code, helps us manage this, and it makes it really easy. Basically, we just have a couple of controls where we sign off on it, ops signs off on it. We get together on calls during maintenance windows, and we click a few buttons, run a few tests, and decide that it's good. Essentially, our load balancers always stay deployed. We never shut those down, and we want those to be consistent. So the steps that we'll run once the load balancer is there, we'll run our CloudFormation, or in the near future, our Terraform, and that will launch our environment, and we'll run the automated tests that help verify that that environment's proper. Assuming that that passes, we have our connectors running at the fan-out layer. We have our new cache layer running, and these will be the latest versions on the latest images with the latest security. And this will be running, in this scenario that I have on the screen, this was a clean cloud environment, a new region, nothing was running, just to illustrate the point. So in this case, everything's good. So we point the load balancers to that blue setup. We'll call that blue 1. And everything's hunky-dory. Customers can connect to the load balancers, and they'll get routed to those fan-out connectors. Now, let's say some time passes. We have some bugs that we've fixed. We have some new security patches, a new version of OS. So we want to roll out a new environment, but we don't want to disrupt the customer's connections just yet. So what we do is we'll follow that same strategy. The blue environment's still running. The load balancers still point to that blue. But now we'll work with ops again, and we'll run our infrastructure as code and deploy a green environment in the same availability zone. At that point, the load balancers aren't aware of it. They're still pointing to blue. We'll run our validation, and then if everything checks out and it looks good, now we'll point the load balancers to that green environment, which has the latest code and the bug fixes, and now we'll repoint the load balancers, and we'll remove the blue environment after some time has passed to allow connections to organically migrate. And we'll do all of that during service windows and maintenance windows, so we're not disrupting anybody during live market hours. So this is sort of the good case where we can do this migration with minimal customer disruption, and it's pretty fast. It's usually 10 minutes. Most of the time is there waiting for containers to start up and EC2 instances to start up. So now I want to walk through sort of the next logical step. So let's say a little bit of more time has passed, and we have new versions of code we want to deploy. In this environment, we do exactly the same things that I just talked through, but now let's assume that that validation failed for some reason. We don't know why during the rollout. The good thing about this strategy is nobody's been impacted. The load balancers still point to that green environment that was up and running and working just fine. So what we do is we just clobber that new blue environment we tried to roll out that didn't work, blue 2, and we shut that down. And because it was all based on infrastructure as code, we can spin that up in another environment, a test environment, a pre-prod environment, exactly as it was here. And the dev teams or the test teams can try to reproduce whatever the problem was that we ran into here in production while we were trying to roll it out. And nobody was impacted. It just took a little bit of time from dev and ops to roll it out and see what happened. So now, sort of the last step in this process, let's assume that time passed, the development team figured out whatever the bug was that prevented it from working. We go through that same process once more. This time those scripts work, the testing passes. So now we repoint the load balancers over to that new blue environment with the fixes. We shut down the green environment, and everything's happy. And this is, for us so far, it's been an effective strategy that works with our continuous integration and our continuous delivery approaches. So as code changes go into our RTDS code bases, we can have that get rolled out. We can pick up new versions of that. We can pick up new versions of our underlying OSs, new versions of our containers, and roll them out safely without impacting existing users. We can even prop up some of these environments and never point the load balancers to it to help drive testing in ways that are safe for us to still test, but in sort of protected production environments. So the infrastructure as code, the containers that we have in RTDS, the functionality with TCP, the elastic IPs, all of this helps support this environment because every time we're rolling out these new things, we're using those technologies. When we roll out a blue, it's using a subset of those elastic IPs. The caches use those DNS names when we switch over. When we roll out that next green, it's using another subset of those elastic IPs. But the configs in the connector layer at fan out knows about all those things, so it's able to resolve them all the time. Whether they're up because the blue's there or whether it's not is another story, but it's going to always resolve something because blue's going to be there or green's going to be there. Matt, how am I doing on time?
You've probably got another minute or two, I'd say, if we can sort of whistle through the last couple.
Perfect. I'm almost done. That's great. Okay, so I wanted to sort of end on a couple of other things. There are some additional connectivity options that we offer, mostly supported by things in cloud. Some of them are available today. So typically you'd connect over the internet, and you'll leverage the encrypted connections out of the APIs to connect over public internet to the load balancers. But there's also functionality called private link. And inside of our availability zones, we have private link endpoints that map to each load balancer. So if you're running inside of AWS, you can create your own private link endpoints that map to ours, and those let you connect from your AWS virtual private cloud to our AWS virtual private cloud where Real-Time Optimized is running without having to go over the internet. You still need to be on the internet to get to your VPC, but once you're there, over private link, you're basically connecting over a dedicated line from within Amazon to get to us. And that's what this image on the left is trying to depict. So this would be on this small box would be the customer's VPC connecting to another VPC using VPC peering, or the green box on the right is showing the customer's VPC going over private link to our service where they happen to be in the same availability zone as us. Then there are some other options that are coming down the pipeline later this year. There's a solution to help bridge gaps with Delivery Direct. It's relying on the same type of idea as Private Link, but instead of having to be inside of the cloud to leverage it, essentially customers would have a dedicated line run from their data center, their office, wherever it may be, to a Refinitiv run VPC at Amazon, and then we would manage endpoints and private link mappings from that VPC. So that allows customers to connect from wherever their apps are running in their data center or their office over that dedicated line to a VPC that Refinitiv is running for them, and then over private link, essentially now eliminating those internet connections entirely because you're going over a dedicated line and then private link, and that whole connection is essentially protected and safe and off of the internet. And then as a subset of that, there's a bring your own comms option that's being worked out, where instead of using a vendor that Refinitiv would be choosing and certifying, you'd have an option to choose your own vendor. Those details are still being worked out, but if you reach out to Matt or Jeff, I'm sure that more information, or Ryan Prout, more information can be provided as it begins to materialize. And then the last couple of things I wanted to mention, and I'll just sort of show these slides. You can go through these as we provide the deck. I have a list here to try to illustrate the functionality in the connector and in our products that we're using today inside of our cloud offering. So these are things that we're using inside of Real-Time Optimized to help provide our service and support the functionality that we want to provide. On the left is a list of functionality that we're using either through the APIs to facilitate connecting in, or through the layers connecting the caches and the fan-outs, or connecting outside of between cloud and our data centers. And on the right are features that we're expecting to turn on in the near future that we're working on testing to continue to grow the functionality and improve the service. But they're all standard connector functionality that you can use today anywhere that you're running the connector. And that's what this next slide is. This is showing sort of the general connector functionality. This goes beyond the features that we're using in Real-Time Optimized. And this is just showing sort of a comparison of the functionality that you'd have if you were running an ADH, ADS setup with multicast backbone, and the features that you can tap into leveraging that full RTDS setup, and then the functionality you'd get if you were running a connector, where it's kind of taking the top half of an ADH and the bottom half of an ADS and combining it together with no multicast. And you'll see that for all the items on this list, the features do have some level of parity. There's more information than this list contains. There are certain things that obviously aren't here because things like hot standby you can't do without multicast. But there are parallels. There's warm standby. There's other functionality that we offer for TCP to help bridge that gap. And these things are available in connector. They're available to run in cloud. They're available to run on-prem. So there's nothing that we're doing in cloud that's specific to cloud only. everything we're doing is trying to use the same key functionality and connector that can be done by anybody, anywhere. And on that, I will hand back to you, Matt and Jeff.
Lovely. Thanks so much, Brian. That's a great in-depth deep dive through what we're doing around our real-time in the cloud, or our real-time optimized service. And obviously all the slides are there. Ton of detail Brian's just gone into, and Mahesh as well. What we wanted to do was see whether anyone actually wanted a follow-up for that. So if you wanted someone here on the team, or someone from your account management team, or your customer success manager to get in contact with you, we're happy to dive on the phone, have a follow-up call with this. If you want that, click on yes, and we'll get in touch with you after the fact and set some time up. If no, then absolutely come back at a later date once you're kind of ready to start exploring this, or once the cloud provider of choice is ready for you guys as well. Okay, so if you want that, click yes. If not, no, and then we'll quickly move on to the next section, which is going to be around DACS, and it's going to be something slightly different as well, because what we're going to be doing is talking around some of the themes that we've been hearing, some questions that came up from previous webinars, and Jeff and Ted are going to go through some of those questions. And if there's anything that comes up in the meantime through the Q&A, then we'll address those. There was also a bunch of really great questions came in, Brian, while you were chatting there. For the sake of time, we'll park those until the end, and then hopefully get to those. We'll try and address every question, even if line after the fact. Some are going to be quite extensive answers, and some are quite quick. So I'll move across. The focus is now on DACS, something a bit different. So Jeff, I will hand over to you and with some questions, and go for it, please.
Okay, thanks, Matt. So as Matt said, we've had over the last couple of sessions, we've had people submit questions, and what we've done is kept track of those questions. So again, the themes are common in some cases. So the first question you'll see here is, would it be possible to port the DACS utilities today from SSL to RSSL? And Ted, are you available? Do you want to address that one?
Sure. Thanks, Jeff. Yes, I would say it's more than just possible. This is one of our features that we're hoping to port at the later half of this year into DACS. A lot of the advantages is we're going to switch from RFA over into EMA. Besides the RSSL port, which you can imagine, that means you don't have to stand up an RTC that supports SSL. The other advantage is then you'll be able to install a DAX station that is 100% 64-bit. As everybody knows, right now you have to install some of the 32-bit libraries on your OS, and the reason was always for map collect, item requirement, perm test, and subscription repair. So that will eliminate that. You'll have a nice, clean 64-bit DAX station.
All right, good. All right, thanks, Ted. The next question is about DAX configuration and support. This was somewhat open-ended, but I did want to emphasize that we have over a dozen manuals that cover every aspect of DAX and for each feature. And with each release, these docs are updated for any changes. And basically, rather than try to address all the topics, because that alone could take 20 minutes, what I'll do is in the follow-up package that we send out, there'll be a doc with a list of the aggregated documents that are available with the links to my Refinitiv, so you can download those. All right. And then moving on to DAX APIs. The DAX APIs we have today, we have both C++ and Java APIs for DAX. One of these questions might have been because somehow the links that were available for these APIs went missing off of my Refinitiv, and so they've been restored on the developers portal, and I will include those again in the follow-up package. So anybody that's looking for the links to the C++ and Java APIs for DAX, those will be available. And then moving on to number 4, Ted, I'll turn this one back for you. This is about performance of Oracle.
Sure. Yeah, so the performance of Oracle, it was mentioned some functions like the Aura Move is very slow. It's not so much Aura Move is slow. Aura Move actually uses the fastest API that Oracle allows, which is called Direct Path. And what it does is it bypasses the SQL engine and writes directly to the Oracle disk drive or whatever your storage is. Now, you don't tend to want to pick Oracle necessarily for performance. Oracle you tend to select because that is your company standard. They have excellent resiliency, right? Nobody's going to beat Oracle databases in a rack system. You also choose Oracle for things like their backup capability. It's phenomenal, right? You can add on an extra package and does wonderful backups. Lots of DBAs understand Oracle. So that's why you would probably want to choose Oracle. Now, the next question, Dax decision to move away from Sybase to Oracle and Postgres. That one's kind of a funny answer, which is Dax didn't choose to, not use Sybase anymore. What happened was, as Thomson Reuters said, we pay for a license, to use Sybase, and we have a number of products. They had a number of products that use Sybase, and that actually came from Reuters, if you remember. We didn't want to have to do that anymore. So they said, look, if Dax wants to keep using Sybase, you got to start paying for it. So we chose, no, we don't want to do that. Let's start switching to other databases. So that's why we got rid of Sybase. It wasn't necessarily technical. Now, why did we choose the ones we chose? That's always a good question. Oracle we chose because obviously it's the #1 used database, not only in our industry, but just about any industry. Just about any large company has an Oracle and a team of DBAs using Oracle. The second one, Postgres, you may say, why'd you choose Postgres, Ted? And the reason was that's the #1 open source database that isn't influenced by Oracle. That is still a relational database. You're welcome to look this up. A lot of this is available. You just Google, it's called DB Engines. And it will show you the ranking, and you'll see that's kind of how they're ranked. I'll turn that over to you, Jeff.
Yep, all right. Next question was about Dax Road Map, and this came from presentations last summer and into even last fall. And we previously did not cover Dax on these presentations. It was really focused on real-time distribution system, and starting last fall, in November, we included Dax in our discussions, and the Dax Road Map was included at that discussion in November. And we've posted the Dax Road Maps on My Refinitiv now as well. And obviously, we are now including Dax again in these discussions and presentations. So that will address roadmaps. If there's other questions, by all means, you can send us in questions. We'll get back to you. But Dax is back in prime time now. Right.
So #7 is, you want to see how Dax is going to work with TREP and RTDS and things like that. So this one, I'm happy to say, hang in there for the rest of this webinar. And you're going to see towards the end, I'm going to cover Dax running in GCP. So, I really like this question because it's going to flow nicely with the rest of this talk. The license requirements in the cloud are still very similar, and that is, for now, you still have to put in the IP and the host name of where Dax will be running. Luckily, your Dax should always be running, so it should always have a host name and IP. It's a little different than on RTC.
Hey, Ted, just while we're on that question, there's a question coming from Prahlad. If you were to run Dax SCP or station in a containerized environment locally, not just in the public cloud, the license linked to the host ID will be an issue. What's your thoughts on that?
Well, there is no license on a syncd, a WANR, or a server, right? The license is only strictly attached to the Dax station.
And what about that from the host ID perspective in a containerized environment?
You would still have to put in the host name. You can still set the host name for a container. But as you know, so far, there is no such thing as a Dax station running in a container.
Okay. I think that's the answer for now, right? That we don't recommend containerizing. Okay, thank you.
All right, and then moving on, Open Dax Permissioning. This was another one of those questions, a bit significant by nature in what we could discuss here. There's a lot of topics we can discuss around this. So I need a bit more detail, but if you send me my email's linked into the doc before, send me a little bit more details about what you want to talk about. And we may even include a session on some open Dax permissioning and tools for the next discussion. All right. And then Ted, I'll turn the last one back over to you.
Sure. So this question is about Open Dax Permission Server. How do I performance tune it? Now, what we have is a developer's guide for Open Dax Permission Server. And in the later half of that document, we also cover a number of things about performance. So you'll see how we tell you how to tune the kernel. Really what it is raising TCP buffers, raising file descriptors. We have a number of things you really should do to your kernel if you want the maximum performance. We also go through in that document every query type to Open Dax Permission Server and what you should expect for the performance. And that is using 1.1 or 1.0 HTTP. Obviously, 1.1 is more performant because you can keep the connection up, meaning let's say you're going to do 10 queries to Open Dax Permission Server. With HTTP 1.1, you can just make the connection, do your 10 queries, request response, and not have to keep creating the connection and tearing it down. And that's, again, documented inside the developer's guide.
Thanks, Ted. There was just a couple of questions popped in just while you were chatting there. We'll quickly try and address these, and then we'll move across to the demo. There's a question from Arcadius, I believe, concerning Dax Station and Tomcat, the default SSL TLS encryption. Is this feature as default?
Yeah, so we use the default that comes from the open source community for Apache Tomcat. You're welcome to modify if, let's say, your site says, we don't want to support TLS, 1.2, we only want to support 1.3. There's documentation on the Apache website that tells you how you can modify the encryption that is supported. But generally, when you think of Dax and what we install for the reference implementation is how we get the configuration directly from the open source community.
Lovely, thank you. And then last question, how many times is typical or per hour for sending the ADS usage data across to SCP? He has some ADS send in the usage file each minute. Does that have a performance impact?
I wouldn't send it every minute. That could be quite a big load. Now, you probably wouldn't want to send it during market hours. As you know, the usage data is quite large. Now, performance on the database probably doesn't matter as long as you're using consolidation. Why? Because if you think about usage when it's collected for consolidation, it just goes into the staging file, right? Which is, many megabytes, many hundreds of megabytes per second we can write to the staging file. But I would probably stay away from once a minute of usage collections. Think more like many hours, or there is a configuration parameter in Dax that you could look up in the manual that describes, you don't have to, if it fills up, it'll collect, but try to collect every day at this time. And what you'll do is set the time outside of market hours.
Lovely. Thanks, Ted. And there was another question coming from Chris, but we haven't got time for that. If you maybe address that one offline through the Q&A, that'd be great. Because right now we're going to jump across to our demo. And we're probably a little bit short on time, so we might have to speed through this a little bit. But what you're looking at on the screen right now is a schematic, a diagram of what we're going to do. So before we dive right into it and Xiaoming walks you through the GCP setup, I just wanted to explain what you're going to see, okay? So you've already seen the roadmap. You've already sort of seen some of the stuff we're doing around Dax. You've heard about the off-the-shelf support. So now we're going to be hearing from Xiaoming, Ted, and Joe about the entire kind of ecosystem that we're going to be running inside GCP. There's a lot going on. So you can see there's 3 Linux instances running in GCP. If GCP is not your preferred partner here, then don't worry, because we're doing the same on AWS and Azure. And as that goes to other clouds, we can do that too. Instance 1's running real-time connector. which is also running a Dax sync daemon in a Docker container. Instance 2 is running exactly the same configuration, but not in a Docker instance. Both of those are connecting out to our real-time optimized in AWS. Instance 3 is running a Dax station database controlling both of those real-time connectors. So first up, Xiaoming is going to quickly walk you through the GCP console, highlighting how that's set up. That's all documented in our real-time connector manual with screenshots as well. So don't have a look at that file through the links section. And then he'll show you the real-time connectors connected in. So I'm going to hand over to Xiaoming, but just before I do, make sure you resize your screen, go maybe full screen on this so you can see everything. Hopefully you've worked out how to do that through the widgets by now. It's the little one that has sort of 4 arrows exploding out. That should go full screen for you. So Xiaoming, I will hand over to you and good luck.
Okay, thanks, Matt. So today I'm going to show the RTC, which is installed. Let me share the screen with you. Okay, so when you first log in the GCP, this is a Google Cloud platform. So you are given the dashboard. So pay attention to the drop down here. This is a concept in the GCP that called the project. So this is the similar concept with resource group, which was used in the AWS and the Microsoft Azure. So let's see, under my account, I create several projects. So I have, for example, I have the dev, RTC QA, and RTC demo. So for today's demo purpose, let me click the demo. So under this project, I manage all the resources. So there's a compute engine, which is EC2 in the AWS, and the storage is similar to the S3 in the AWS. So let me click the computer engine. So under this project, we saw we have the resources or the virtual machines. And for example, the one we have the virtual machine which installs the DACS cluster of the component. So for today's demo, I am going to use the virtual machine of this. This is I installed the Docker version of the RTC, and I'm going to use this one as well, which installed the non-Docker version of RTC. And the third one is virtual machine. I installed the test tools. So how do we enable that? So currently, we see the status, all the virtual machine is powered on. So if we can turn it on. This is one way. Click the start. Click start. So the virtual machine will start. And the second way, we can use just click check here, and you can start from this way as well. So all the machines in the process of the power on. So once the RTCs or the virtual machine is powered on, all the RTC applications will auto start. So you can configure that way. So once the virtual machine is started, you can use the SSH to log into the virtual machine. There's a couple of ways to use the SSH. You can use the SSH client in your local laptop, but in that way, you have to manage the key pair, the private key and the public key. But the GCP, they provide a pretty nice tool they call the browser SSH tool. So in that way, if you click the SSH, so you can SSH log in. You don't need to manage the key pair. So that is very handy for me. Let me try this. So I start the Docker version. And I'm going to use SSH non-Docker version. And I'm going to use SSH to the test client. Okay, let me move the console side so we have the better view. So to verify let's verify if the Docker version and the non-Docker version is up and running. Let me do the Docker PS. So we see, so the RTC container is up and running, so it's giving the container ID. Let me verify the non-Docker version, RTC. Okay, it's good. So RTC is up and running. Now, when the container and the non-container, the RTC up and running, it's going to search for the service for the upstream, the data feeder. So in our case, they are going to search for the real-time optimized data feed, which is located in the AWS. Let me verify if it is already make the connection to the upstream data feeder. I can do, let's say I can do this way. I'm going to use the RTC monitor to see. RTC, I'm going to use the monitor and so I'm going to check that service. So now it shows to me all the connection was set up with the upstream, with optimized, real-time optimized. So it's good. And for today's demo, I'm going to use the Unix DD, which is provides the 330 millisecond trade safe service. So I'm going to use that service for today. The same thing. Let me log into the Docker version. So I will use the ID here, and Lisa, I'm going to use the same tool, monitor tool, and verify. So we see here, both are connected to the upstream data service. That's good. Now I'm going to show you the downstream, the data connection. The downstream, I mean the connection between the RTC and the data user to see what's the status now. Let me get up here, and I use a user stats. See, this is a list of the users, so it shows there's no data user connected to the RTC for now. So the same story here. So there's no connection. So next, I'm going to use the test tool. This we call the test client, which simulates the data user, which will try to make the connection to the RTC and request for the data. So for today's demo, I created two kinds of the users. So one user is entitled to access the New York Stock Exchange with NASI data exchange, but not on the NASDAQ. So for the second user, it's going to be permission to access both exchange. So I'm going to show both test case. So in the test case one, for example, so we have the test client, and this is the service name, and this is the user, what I said, is entitled to access the New York Stock Exchange, but not on the NASDAQ. So it's going to request, for example, the IBM, and this is the IP address of one of the RTC. So for this case, it's going to execute the first command. So I expect its data will go through because it's entitled to the NASI. Here, and see the data is keep updating. So the data is approved. The data is up and running. Now let me move to change the script a little bit. Comment this out. Let me the user trying to get this Google, which should fail because it's not entitled that way. So here, we can see the access is denied because the user tried to get the NASDAQ, but it's not entitled in the DACS. Oh, by the way, look at the RTC monitor here. So we saw this is the username, and the connection was built up between the RTC and the server, but the open item is 0, means the user cannot get the instrument because this is denied here. So next,
so it's just So I'm sorry to interrupt, but we're probably running a little bit short on time, so I think we might just want to step through to the next part with Ted.
Okay.
What you've seen there, you've seen the data already coming in for one user that's entitled for it, but also getting a DACS access denied, just proving out that end-to-end kind of connectivity between the instance and the DACS station. So Ted, can I hand over to you just to briefly run through sort of the DACS functionality in GCP and how that compares to on-premise DACS? Are you there, Ted? Is there a big red mute button showing, Ted? All righty, maybe not. Joe, are you available? Maybe we'll jump straight down to the REST monitoring.
Sure, Matt. We can flip to that real quick. I think there's a slide that shows. I'm just going to bring up a web browser that's on my laptop. That's just coming into GCP into each RTC. I'll just show you guys real quick what it looks through like a web browser. But you can use any technology that uses REST JSON. So just curl, and you guys can build your consoles on top of that. So let me share my screen quick. So here's just a landing pages for going through a web browser. Again, I'm on my laptop connecting into RTC over the internet. You can see we have 3 manageability resources. We have configs, shared memory, and item database. Configs gives you read access to all the configuration file and all the parameters. Shared memory, anybody familiar with ADSMon, ADHmon, mob print, mob, the -set, -get options will be at home there with the shared memory resources. It does support both get and put. So any parameters that are changeable through shared memory today, you can use put on those as well. And then our item database. Obviously, we have item database dumps today, but you have to go on the file to collect those. Anything to the item database resource here will come back through and onto your REST response. So it won't require you to go onto that machine. As far as security, we do have optional encryption. We have optional obfuscated security keys, so you can set up different security keys for the different resources. Excuse me. And then we also have IP whitelist on the server side, as well as we have optional audit logging, so administrators can see who's coming into that interface and doing what actions to it. Just to kind of show real quick what this would look like if you want to just get a dump of the entire configuration file that's currently being used. You can just go in configs, and then again you can narrow it down to specific parameters, routes, anything you want from there. As far as shared memory, again, if you wanted a simple mob print shared memory, just go into your shared memory. It's going to come back. It's going to be in JSON format, and it's your entire mob print basically right there at your fingertips. And again, from here, you can go into different classes. If you just want to see the list of classes that are available, just go into classes and you can go from there. Okay. And as far as the item database, again, you can do cache dumps, as well as database dumps of the state of the items. So anybody familiar with database dumps, this is the format that we returned today. We didn't want to change the format because I know probably a lot of you guys are parsing some of this today, so you can use the same parsers on the response back here as well. There's one fourth resource we have is called Snapshot. So we released a REST Snapshot server in 3.5.0, I believe. So if that was enabled, you'd have access to that as well. So for sake of time, I'll hand it back over, Matt. Thanks.
Thanks, Joe. Appreciate that. And a bit of a whistle-stop tour, maybe something we can dive into a little bit later in one of the other webinars, because I know there's a lot of interest around that REST API, especially as we do move into sort of the lockdown world. So out of the back of that, we've talked about AWS a fair bit. We've talked about GCP. We've mentioned Azure on the roadmap. We haven't talked about Ali Cloud, although some of our customers in Asia are definitely interested in that. So what I wanted to do was just put the question up on the screen right now. If you're able and willing to vote, then that'd be great. It's all anonymous, I believe. So if you want to vote, then it would be useful for us to help shape our roadmap. So if you're considering moving RTDS capabilities to the cloud, which of these cloud service providers are you thinking of partnering in alphabetical order with no preference. If there was an aardvark cloud, we'd probably put it up there first. But if not, Ali Cloud, AWS, Azure, GCP, or other. And you could put that into the Q&A box if there's another cloud provider that you're thinking of. So again, Ali Cloud, AWS, Azure, GCP, or others. So thanks for those that are already voting on that. I'll give it just a second more, and then we will flip across and see where we're going with that. Okay, let's see what the kind of ratios are. So there we go, a good kind of cross-representation of the people voting. So Ali Cloud not at the moment. Maybe when Asia wakes up and listens to the recording, they might have skewed that result. AWS leading the way, which kind of jives with what we've been seeing, but Azure, good representation, and to a lesser extent GCP. So that is really useful feedback. So we do appreciate that. Thanks very much. Okay. I did want to skip through to the next one. We've got 5 minutes. We're going to cram it in. This is really going to be kind of like celebrity squares with all of our development leads in, giving the most buzziest answer they possibly can to what they're working on in this quarter. So first up is Brad, who leads our value-add services. Brad, did you just want to give a quick minute update on what you're focused on, please?
Sure. Thanks, Matt. So I'm Brad Bueller. I'm development manager of some of the value-add products, such as ATS, DPS, and a few others. Focusing on today is ATS. So just released some pre-built container images out into the Refinitiv Real-Time space on Docker Hub. We're following that up now with qualification of ATS in AWS, our regular packaging. Also taking those ATS containers, qualifying those out on AWS, more in the category A support. And then another thing that we're working on is the ATS password policy updates. So we kind of be looking similar to what Dax has in place, but it's going to be a little bit more user-friendly configuration with an ATS, kind of the UI pop-out. So it'll be easy for resiliency setup. Won't have to be done before the ATS started up, but more from a UI perspective, so it syncs across the resiliency and the different data centers, different instances as far as the normal leaders and primary leaders. So we're also going to have more of a password days reset, so 90 days, or it's configurable by the admin that is setting up the ATS side. But that is kind of the quick snapshot of what we're working on and what's going to be coming soon.
Thanks very much, Brad. And if anyone wants more details on what our kind of ATS roadmap is and what we're doing, and maybe a bit more of a deeper dive on, you can put that in the feedback or in the Q&A, because we're happy to add that into the webinar if that's something people are interested in hearing more about. Okay. If I move on to the next celebrity square, that'll be Vasavi, please.
Thanks, Matt. Yeah, here you see what we've done in 2021, as well as what's coming up. Just a quick recap. We have delivered the WebSocket transport and a separate conversion library with the Java RTSDK, as well as server-side encryption. Over the WebSocket, you could do JSON. Of course, it's also with the conversion library, you can use that independently, or it's also used to do auto conversion in our reactor layer at the ETA Java. Upcoming, quite a few things here. The first thing there, off to the right, you see a little image of the tool that I'm referring to in the first bullet point there, which is the real-time market data viewer with, of course, connectivity into RTO, the real-time optimized cloud connectivity. Also coming up is an enhanced authentication with RDP, which has both the token-based as well as certificate-based authentication. We will be in Q4 aiming for warm standby feature within the APIs for better resiliency. Also, we aiming to produce a report that sort of gives you a comparative analysis between the various APIs, the C edition, the Java edition, the WebSocket, as well as socket transports. So that's a wrap for the API update.
Thanks very much, Vasavi. And again, an API definitely of interest. So I think we'll be looking to do another session on that and focus on that in one of the upcoming webinars. Mahesh, are you back online now? And are you able to give your update, please?
Yeah, I hope so. So yes, so I hope you guys can hear me now. So yep. There's a lot of performance work that we are undertaking. One of the fundamentals that we are looking at is the payload size for the updates. So we use a standard of 74 byte, and that is consistent with some of our observations when we take a 1K watch list or something from ERT. But when we look at something like S&P 500, we are seeing that the message sizes are more between 125 to 130 bytes. So we will look at a couple more examples and maybe update the message size in our sample XML in 352 at the end of this quarter. And then we are also doing some other performance analysis more for RTC as a caching layer, replacement for ADH, and then the rest snapshot that was released in 350. And there's a lot more interest in warm standby. So we will be working on that this quarter and next quarter, and hopefully release something out in Q3, Q4. And then there is also some work underway with Google. We have, had conversations to see, we do lots of tuning for getting optimal performance for RTDS and RTC on-prem, and how does that translate when we go for a software-defined network in GCP? So that's another thing that we are working on, and we expect to have something by the end of this quarter there. And we are also benchmarking RTC and ADS with the Refinitiv Workspace. We have some data for the performance of WebSocket, but Workspace uses views, dynamic views, and they also have compression. So we want to take those things into account and produce a performance report on that. So that's it from me.
Thanks, Mahesh. That's whistle-stop tour. I know we're already over time. We've just got a couple left, though, so if you could bear with us just for a couple more minutes, that would be great. Otherwise, I understand if you have to drop off. Joe, over to you, please.
Sure. Thanks, Matt. Jeff covered some of these in his roadmap update already, but I intermixed some small enhancements as well. We constantly try to strive to work on some smalls and continue to progress the platform. Obviously, we're working on integrating Dax Sync into our containers, Cat-A support for Azure, WebSocket encryption, thread binding. We're trying to finish up that story there, trying to bind the remaining threads that we have and go through and really kind of clean up and make consistent logging and monitoring for you guys, because that's extremely important for you. Limiting non-interactive cache sizes was a couple of requests we got from some customers. And again, trying to help you guys with some of the REST stuff. We know that your responsibility is on you to kind of build that console, but if we can kind of predefine some REST queries for you, I think that'll be a huge help. Similar to what we do for ADS-Mon, ADH-Mon, dash print options, if anybody's familiar with those. And again, trying to continue to focus on additional resiliency options between warm standby, BGD within the RTC, and then some options around the round trip time as well. Thanks, Matt.
Thanks, Joe. And Ted, are you back on as well, able to give a quick update on what you're working on? Ted, no, I think we've exhausted him with the Q&A session. So let me just quickly jump to what's up next time then. More events, forums, webinars, developer days are coming up. So we'll try and keep you abreast of those. Said focus on APIs. If there's other stuff you want us to focus on, absolutely. We're happy to be led by you in terms of what the topics are. And we're just trying to make sure it's as relevant for you guys as possible. More documentation. We're continually cranking out new documents, updating that. A lot of the stuff around the CSPs, et cetera, too. So look out for those. Are all on my Refinitiv. There's links in the link section. More software releases, obviously, as we just talked about. Potentially more bad T-shirts or more bad dress wear when we see you guys again on the webinars. So I just wanted to wrap up and say before we go, there's a feedback form after this. You can put your feedback in, guidance, constructive criticism only, please. And I wanted to say thank you to all of the team for presenting and the rest of the team that aren't presenting that have supported this. A lot of effort goes into pull this together. Hopefully you've seen that. And we really enjoy doing them. Hopefully you enjoy listening to them. And we will speak soon. So with that, I will say good day and thank you very much for your attendance.
Thank you, everyone. Thanks, Matt. Great job.